Now in the previous video, I said that we could quickly graph this in y-intercept form if we could work out both the gradient of the line and the y-intercept of the line. And we could graph it in the form of y is equal to our m value multiplied by x and plus our c, where our m value was our gradient of the linear line and our c was the y-intercept. Now sometimes we can quickly identify what our y-intercept is from the graph, sometimes we can't, or we might not even have the graph at all, we just might have these two coordinates here. Now in this situation here, the y-intercept is not a whole number, so it's not as easy just to quickly find what this c value exactly is by just looking at the graph. So let's look at a technique that we can use to be able to find the equation of this linear line only using the two coordinates. So we've got the coordinate -1, -2, and the coordinate 5, 2. Well, let's start with the slope, because the slope is nice and easy because we've got 2 points to find the slope of. So to do that, we can start by labeling this. So we'll label our x coordinates as x1 and x2, and our y coordinates of y1 and y2. And our slope formula is m is equal to our rise over our run, or our y2 subtract our y1, divided by our x2 subtract our x1. So when I substitute these values in, our y2 will be 2, subtract our y1 of -2, and our x2 is 5, subtract our x1 of -1. Now, whenever we're subtracting a negative, it's the same as addition. So to subtract -2 will be +4, 5 subtract -1 will be +6. So therefore, our slope is equal to 4 over 6, which simplifies to 2 over 3. So now I've got the slope of this line. What I can now actually say is the equation of our line must be equal to y equals our slope of 2 over 3x plus c. I now just don't know what this c value exactly is. But there are other properties of this line that I do know. I do know two separate coordinates that exist on this line, and I only need to use one of these to be able to determine what our c value is. Because I know that when our x is equal to -1, our y is equal to -2. Equally, I know that when our x value is equal to 5, our y value is equal to 2. So if I substitute our x and our y of one of our coordinates into this formula, I can then solve for my c and find what the y-intercept actually is. So let's have a go at that. Let's substitute this value here. So when our y is 2, so our y is 2, our x is equal to 5. So that means I will substitute our 5 in here. So now let's just quickly multiply this out. So our 2 will equal 2/3 times 5 will be 2 times 5 is 10, so it'll be 10 on 3 plus our c value. So when I subtract 10 over 3 from both sides, what we'll have is 2 subtract 10 over 3 is equal to our c. So if I can do 2 subtract 10 over 3, I'll find what my y-intercept is. So 2 as a denominator of 3 will be 6 over 3. So our common denominator will therefore be 3, and then 6 take 10 will be -4, so it'll be -4 on 3. So our y-intercept is -4 on 3, or -1 1/3, which you can see on our graph here, that's passing around that point, so it seems about right. So you can see here that this point here will find the value of our y-intercept even when it's an irrational number. So what we do with this now is we just substitute it back into our equation. So our equation of this linear line is y is equal to 2/3 x, and because we've got a negative, it will be subtract 4 on 3. So to summarize here, if we know two coordinates that lie on our linear line, we can immediately find the slope of that coordinate without even needing to actually draw this graph, and then represent our equation of our linear line, just leaving our y-intercept as c. What we then do is we substitute one of those coordinates, it doesn't matter which you substitute in, and solve for our c, which will find our y-intercept of this linear line. And then you can represent this equation in y-intercept form.